Welcome to the Walton Pi. Today we are going to go through some examples of exponential functions. So let's look at y equals e to the x. So this is one of the ones that we were talking about, and this is going to be the graph of that function. Some special points to notice are this point right here, that is 1, and then it's going to be increasing at about this rate. An interesting property of e to the x is that the slope right here, this has a slope of 1. This will come up later in the course, so that's something useful to realize about e to the x. And if you're needing a little bit help, e is about 2.7. It's a little bit bigger, but if you're having a hard time guesstimating what value to put for e, it's about 2.7. So this is the graph of e to the x. Other functions that we might have might be like y equals e to the negative x. So if you might recognize this from function transformations, that is going to be reflecting it across that axis. So it'll go like that. Again, still intersecting here at 1. Now, a nice property is that any exponential function always is going to intersect at that point. So if we have y equals a to the x, this is always going to be something like this, where this point right here is always at 1. Now, this graph is only if a is greater than 1. If a is less than 1, we are going to get something that goes the other direction. And the weird case that we haven't dealt with is if a is equal to 1. And so these are the different exponential functions that we will see, although we normally don't consider if a is 1 to be an exponential function. We consider that to be the constant function. So some nice properties of exponentials that we can go through some examples are that a to the b times a to the c, this is equal to a to the b plus c. And if we have a to the b all raised to the c, this is going to be a to the b times c. So let's go through some examples of how we might be able to combine these. So let's try and deal with what is 16 cubed times 49 squared times 27 to the 5th divided by 2 to the 18th, 3 to the and 7 to the 5th. Let's try and combine this to rewrite it a little bit easier. Well, none of these have the same base, so none of these are written with the same a value, but some of them we can rewrite that way. For example, 16 is 2 to the 4th, so we have 2 to the 4th cubed, 49 is 7 squared, and 27 is 3 cubed. So this does actually help simplify quite a bit of these terms, because now what we have is using this rule that we have right here, our rule for exponents, we are able to rewrite the top as being 2 to the 12th, 7 to the 4th, 3 to the 15th, and then the bottom is still going to just stay exactly the same, 2 to the 18, 3 to the 8, 7 to the 5. Now, fortunately, quite a few of these terms are going to be able to cancel out. So this 2 to the 12th cancels with most of the 2 to the 18th, and we're left with 2 to the 6th on the bottom. This 7 to the 4th cancels with most of the 7 to the 5th, and we're left with a 7 to the 1 on the bottom. And then this 3 to the 8th cancels with that, leaving us a 3 to the 7th on the top. So this that we started with is all equal to 3 to the 7th over 2 to the 6th, 7 to the 1. This is one place that those exponent rules are going to be useful. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already, so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.